build the defense strategy. I would like to invite to this stage Master of his Business, Technical Director of MTS Red, Denis Makrushin. Let's welcome him. Hello, Denis. Hi. Don't fall asleep. Hello, everybody. Thank you. And I would like to begin my presentation from illustration of what is really happening here. Here, I mean, in industry of informational security. This is Safari. Well, there's a certain symmetry, inequality, where the victim has to learn about its attacker when it attacks him. There is something similar, symmetry in the cybersecurity industry. We as those who are defending part, we have to study the predators only when they come into our infrastructure, when they are running away with our data, and the attacker knows about us, even without touching us, without touching our resources in advance, understanding how do we live, what we do, how our internal systems are built. And I think that researcher is a person who creates to reduce this asymmetry and ideally make it be one step ahead for those who are protecting. My name is Denis Makrushin. I'm a technical director in MTS Red. I'm creating technologies. During free time from work, in cybersecurity faculty, I'm fighting with illegal use of computer encoders, cryptography, and I'm fighting against ransomware. And sometimes I search for vulnerabilities and I write about them in my blog. And right now I would like to tell you about who is researcher or security researcher. What is the difference? What skills from other experts? And we can look who are those experts in general in information security. And today, colleagues and previous speakers have been telling us about different areas, different industries. Some people are involved in SOC, fight threats. Some people in other departments, in blue team, red team. Some people protect the security perimeter. So where do we have researchers here? So you know this game. It's selecting the person in Diablo. You have to select somebody so that you will continue developing his skills, and then it will depend on which competencies you will pull up, which points you will receive. If those who think that researcher is in the center, this big guy, please give me applause. Who think that a researcher is in the center? No, nobody thinks that. However, those who think that this is a pen tester or analysis specialist, ethical hacker, give me hands if you think that this big guy with hammer breaks everything. Okay, yes, we hear some. I think pen testers are the guys who use a little bit of magic and power. This is the girl with stuff. But those who are in red team use more accurate techniques, maybe precise tools. I think they applied some kind of a girl with arrow. But security researcher or researcher is a necromancer, is a magician, because they work with unknown things, sometimes things which seem that they behave not the way they should behave, and everything, the way how he deals with those things defines and determines his competency, the set of tools they use. For example, what's the analogy between necromancer and security researcher here? In research, there is something unknown. When you are being told, please make analysis of a known threat, you don't understand if it's unknown, what is to be analyzed, and there's a certain contradiction in it. High level of uncertainty, high level of unknown. It's something that researcher works with, and the skills for him are very specific. He needs to know to ask questions. This person needs to know to solve the problem by connecting different domains, different expertise. Something should be taken from pen tester, from paladin. Something should be taken from this big guy with the hammer. Something should be applied for the first time in life, when nobody have applied this in the industry before you. And in general, the sequence of actions of any security researcher, any researcher, not just a cybersecurity researcher, is very simple. There's a certain problem. For example, there's a certain unknown threat which comes to our network, how to fight against it. The problem can easily be formulated by top manager, by the client, by mentor, anybody. The problem is known to anybody, but how can we solve it? Researchers should answer it. Researchers should provide a hypothesis. And this is the main skill which differentiates him from from other specialists in cybersecurity area. Ability to quickly generate hypotheses, ability to check this hypothesis, ability to plan tasks on the basis of this hypothesis. This is a key step here. If you know how to generate some assumptions, quickly check them, you know how to deny them and go to another hypothesis, then you are a researcher. But which skills do you need in order to solve these tasks? From the hypothesis, you form the list of objectives, the list of skills which have to be studied, and superpower of the researcher is that he can digest any skill. If needed, he will become pen tester and will do the protection test. He will study basic techniques, reverse engineering, and will be able to look at some complicated things. If there is a need, he will apply async skills, and if needed, he will become attacker and will look at the system from the side of the attacker. The result. Something that is given by the researcher. It's not just a report, it's not just some kind of vision of this reporting, but in the result, we discover something that is called innovation. Innovation of that system, knowledge, which prior was not known and was not synthesized before you. And what differentiates good researcher from a daily, middle, average one is that he's not just putting the hypothesis to the result, but he also creates the hypothesis and some innovation is being created from this hypothesis. For example, a new technology. And right now we'll make several examples from my research because I've started my career as the security researcher by generating hypotheses and being surrounded by skills which are needed to confirm these hypotheses. The most important question which you as researchers should ask to yourself, irrespective, even if you work as a developer or you work as a pen tester, maybe you are not related to cybersecurity industry at all. What if? What if I will try to change the parameter? What if I will not receive from the user input into my system? What if I will not validate it? What if I will change this user input? What if I will change interface? What if in my machine or to my machine I will connect flash card which will have some payload and won't this machine stop? So this is the question that brings you to the creation of the hypothesis. What if? Then people said, if you want to change the world, start with yourself, with the question, what if my home router is vulnerable? I've started clearing the competencies of the security researcher, what they need. I just took my home router, which I received from provider, and I've looked at it from the point of view of the attacker. What if? What if it has some vulnerabilities? What should I look at to find these vulnerabilities? Which skills do I need, competencies? What should I pump up in order to start searching for some problems there? What if the account in my router, it's very simple to be able to brute force. What should I do to brute force these accounts? What should be done to do it automatically? Which competencies do I need to learn? And by asking the question, what if, to the object of your research, you get some objectives. For example, study vulnerability search skill in web applications, and then I start understanding that I have to study this particular topic. Study reverse engineering and try to understand from which internals this software consists in my router. Try to brute force the password and study tools necessary for this. And by acquiring these skills, you are in roles of pen tester, analysis specialist, reverse engineering, the person who knows the code. And in the end, when you bring all of this to the result, be confident if you will take your router and start learning about it, and instead of dropping it in the middle of your path, you will get some result. You'll get the vulnerability. You'll get some deficiencies, which in the future can be provided to the client. I found the account by default, which cannot be changed. So anybody could brute force the password to my router and do some bad things. I found a problem in the software of this router, vulnerability, which allowed to compromise this router and do some bad things against it. And I've prepared a certain report for the manufacturing company, where I described all these problems. I've sent this report to them, and I've understood that It's not just enough to transfer this knowledge. You have to explain it. You have to be confident that another site which receives these problems should fix them, and they understand what is to be done with them. And for this, you have to become a communicator, the one who can effectively and simply explain what was discovered. And for this, we need communication skills. And communication skill is a fundamental thing if you work in any company where there's more than two people. You already have to properly communicate with these people. You have to properly explain complicated things that you are doing. But next, I didn't stop on the router. I thought, what if critically important devices which are surrounding us have the same problems? So I came to medicine, because medical devices are the devices which directly influence our lives. Vulnerability can kill. Yes, everybody remember research. If you don't read who and how, we're finding vulnerabilities in cardiac stimulators, things that is put inside of the heart of a person. You cannot replace it just like that. So the device, medical devices, became the next object of research for me. And as a researcher, I've asked, what if the same problems which are on the side of the router and the same tools which I've been using to analyze my own router are applicable for this big thing? This thing, I don't know, do we have medical specialists here? You know what kind of a device? It's doing sequencing. And it's very expensive. Just break it as a router. You will not be able to do that because it costs like several apartments in Moscow. Well, speaking about it. So you have to be very accurate with it. My objective was to understand what if it has same vulnerabilities or similar vulnerabilities that I was finding in my router. And what do you think? Vulnerabilities were discovered because nobody before the researcher prior to me have never been asking himself whether these vulnerabilities are there. So this thing could do something wrong. It could give the wrong analysis test to somebody, and the doctor could give wrong therapy to somebody. It could change something in the life of a human being. But what skills were useful for discovering this bug, finding this problem? Same skills. Vulnerability search skills, report writing skills, reverse engineering skills, and some skills of async to find how many of those devices are located in the internet. Let's move on. What if development process of the software development is vulnerable by itself? In other words, our research is going deeper and deeper, you're going deeper and deeper, and we have discovered the router. Then we apply this knowledge to bigger devices and more dangerous devices. And right now we are moving fundamentally. What is the development and creation process is vulnerable? If it's vulnerable, on which stage and why? And then we've discovered that attackers and bad guys in general who are involved in breaking supply chains for the development, but breaking the developer, compromising developer to make some bad things on behalf of him in the code. So they are very pragmatic looking at their objectives. For them, the less movements you should do to break infrastructure of development, the better it is. And this graph that you see here, it shows you that the more is the number of steps that attacker does in the infrastructure wants to break, there's a high level of probability that he will be discovered. So it's better to poison the developer, and he will do everything by himself. So me and my research team decided to do our research of supply chain attacks research. We understood that developer is a lazy person and he uses and reuses a lot of open source tools. He doesn't write code by himself. He just takes this ready code from somewhere. Why should you invent bicycle? It's the way you should work. But the fact that he takes these bricks and blocks and adds them to his own code, it does mean that it's safe, and it's not the fact that it doesn't have any implants or injections. That's why we've looked at the development process, which consists of several stages. Stage number one, you create a code. Developer writes a code. The next stage, when this code is assembled together with some libraries from open sources, when it's assembled into a certain package. And stage number three, when this package or application is being exploited by a client of this developer. We've looked at the most important stage, the stage where a lot of dependencies are coming when developer, well, uses it as a black box, some bricks, and we have assumed, can this stage be compromised, and how the developer is vigilant. And can you put into his development cycle some malicious code? Yes, it's possible. What did we do? We generated a hypothesis. We have assumed, what if packages which are located at GitHub, well-known code repository, what if these packages could be infected? How? What are the ways? And we've made on the whiteboard all types of attacks which can influence on changing this package, change its code, or make the developer download the wrong code. And on the basis of these attacks, we've selected the simplest one which are possible. We've called these attacks repo jacking or repository jacking, and developed a methodology of conducting this attack. We've scanned the whole GitHub, all repos. Then we've discovered which repos has links and which repos can be hijacked, accessible for re-registration. And step number 3, it means that if some repository is available for re-registration or some link which is used by developers or thousands of developers is accessible for re-registration, it means it can be hijacked. It means that it can be cut, and that means that anybody can place the malicious code. And on this malicious code, one of the developers will link to it, write a link to it, somebody who writes big critical financial application. So this slide shows us that we have done a design of a certain algorithm. We've designed the algorithm or the sequence of actions of the attacker. And then we created a code which reproduces this sequence of actions. The result of this work, we found about 1,000, more than 1,000 repositories accessible for being hijacked by anybody. Anybody right now can come to this repository and place the malicious code. And right now, some of the developers will download this malicious code. What helped us in this research? Well, the same basic skill, ability to generate a hypothesis, ability to be on the side of the attacker and understand what attacker can do, what sequence of actions will be reproduced to get to this target. So basically, from the hypothesis, we've been creating a task for checking and rechecking for reproduction. And in this research, we needed also the skill of development. Yes, we're not developers. Researchers very often are bad developers, but they can do certain tasks very good. They can automate any routine. And the previous speaker, Lydia, was saying that if you're burning out, use the mental techniques. One of the biggest advices was don't burn out, or that burning out is a regular part of life. Well, you shouldn't burn out if you know how to write applications. If you know how to develop in Python, you will guarantee yourself that you will not be burned in some place. So study automation. Automation helps you to save yourself from burnout. And reporting and vulnerabilities. Reporting is the ability of speaking simply about complicated things. It's a basic skill of any researcher. Because if people don't understand you, no matter how cool is the problem you discover, no matter how global this problem is, nobody will understand you to fix it. And the next question, even more fundamental than the developer. What if a human being is vulnerable? And I will show you a small video here. We create a lot of technologies, machine learning technologies to search for anomalies, complicated systems of correlation and event collection, technologies which don't allow people to make a mistake. But at the same time, there's always a human factor. And while person is a part of a system, he is the weakest link. And as we see from this video, social engineering is a fundamental problem and even the fundamental vulnerability that can be found in our head. How these vulnerabilities can be fixed? Well, there's only one patch, is self-education, and exclude person from the equation. And please remember that researcher is not a person who discovers a problem. To discover a problem, it's the stage number 1. Stage number 2 is to invent a technology which is going to solve this problem. And that's where innovation is. We're here to save the world and not to create problems. That's all, my dear colleagues. Thank you.